Hi everybody, so we'll continue talking about still the topic of probabilities and understanding the statistics, and here we'll change gear a little bit to the variance and start the deviation, and we'll try to variance and standard deviation. And I put for you this histogram here. So the variance will measure the dispersal or a spread of a distribution about its means. So how spread is the data about its mean? And as you see in this graph here, this is like we did before, a histogram of two probability distributions, right? And we saw in beginning of chapter 7 this histogram, and I did an example on it. So the variance is going to deal with this dispersal or the spread. Let's just call it the spread, all right, of a distribution about its means, right? About its means, its mean. So the more closely concentrated the distribution about its mean, the smaller the variance will be. So as compact as it's going to be, as closer as it is to the mean, the smaller the variance. All right. So that's one thing to help you understand it. And the more spread out, the larger the variance. So larger variance means more spread out, right? Distribution. So the probability distribution whose histogram is drawn here in 1A has a smaller, right? So you see compact, so we can see here smaller, right? And you see this one, how it's spread out, not same. It's going to be different. So now let's define the variance of probability distribution. We're using X is the random variable, right? With values x1 to xn and respective, of course, probabilities p1 and p2 and stuff. Then the deviations of the outcomes from the mean are going to be that difference, right? So you know, if we just say the difference between 5 and 2, so you're comparing, then you subtract it, right? So now if we're interested is how far is the outcome from the mean, then x1 minus mu, right? How far is x2, then x2 minus mu, and so forth until we get to xn minus mu. And p1 is the probability, p2 is probability, and pn. So the variance of probability distribution is given by this formula. All right, so the probability of the variance of probability distribution is given from that formula. Let's look at this example, how we're going to compute the variance. So here you're not given a frequency, you're given a probability, right? And you're given the outcome. So x1 f1, this 0 times 0.01. So 1 times 0.3, 2 times 0.5, 3 times 0.1. You know, the formula we add, and we get 1.6 That's the mean. So now to calculate these, let's the notation for random variable, the calculations of variance. So these are nice to do in a table. So we can start with k to be that 0, 1, 2, 3, and let's see for this random variable. We have 0.1, 0.3, 0.5, 0.1. Then k minus mu, we have 0 minus 1.6. We calculated mu, which is the mean. 1 minus 1.6, 2 minus 1.6, 3 minus 1.6, negative 1.6, negative 0.6, 0.4, 1.4. Then you're just gonna square this, right? So as you see here, k minus mu square 2.56, 0.36, 0.16, 1.96, then if you multiply this by the probability, we get, we have all now in the table, we get 256. All right, so the variance is the sum. Point 256, we add 0.108, we add this, we did this, so, right, so it's going to be this, of course, here when you add, and you get 0.64. All right, there is, of course, alternative formula you can see in the book, and just this is more of a technical thing, and with technology you can also calculate the variance, and there are more examples on it. So what is the standard deviation? The standard deviation is a square root of the variance. All right, so if we know how to calculate the variance, then we can calculate the standard deviation. So for this given problem, standard deviation, if we'd ask that question, then it'd be a square root of 0.64, right? Which is 0.8, right? So you'll see in the book and the homework different examples. I can explain these other ones as well, but everything else here now it just turns into formulas and applying them. But the important part is to understand what does it mean when you have a high standard deviation and when you have a low standard deviation. And now standard deviation is connected with variance. And I mentioned variance is, if it's large, means it's more spread out, far away from the mean. And if it's compact, it's smaller, So that same thing now will connect with the standard deviation because they're in close connection. Standard deviation is just a square root of variance. Now, it's not like a reciprocal or something. Then they have some opposite relationships. I will let you figure out, as you will see with the other videos that you already have with this course. It's just a matter of applying the formula. So now you can see, if you follow my videos, you'll see now that the variance and standard deviation of a binomial random variable is given with this formula NPQ, and standard deviation is its square root. So the population variance and standard deviation, it's same way again, where you find that difference u square and the n, and this is the same formula for standard deviation. And you can look at the textbook and do some examples, and I give you some of the examples here that you should pick. But of course, I'm not going to go through them in this video because you have them in the textbook, but I did explain how you build a table. Similarly here, you will do that to build this table, because you have the x that's given. Then you just need to calculate, you have the frequency, then you need to find out the x minus the mu, then you need to square it, then you need to multiply it by fi, right, for this formula. And similarly here in these other formulas. So now you can easily follow these type of problems using the previous problems that we did. However, I'll talk here about Chebyshev inequality that says, suppose that a probability distribution with numerical outcomes has expected value mu and standard deviation, right? Then the probability that a randomly chosen outcome lies between kind of average or mean minus a c and the mean plus c. It's like an upper bound on a lower bound to the mean, like think about it, maybe a distance on the right side and the left side. Inclusive is at least that number there, right? So let's do it. Let's do it through this example. Suppose that the probability distribution has a mean 5 and standard deviation 1. Use Chebyshev inequality to estimate the probability that an outcome is between or lies from 3 to 7, right? All right, so it's just a matter of using the formula. The mean is 1, the standard deviation is 1, the mean is 5. So the lower bound is 3, the upper bound is 7, right? So these two give us CS to be a 2. Then now 1 minus standard deviation 1. Let's write it down. 1 minus standard deviation is 1, square is 1, and c is 2, so 2 squared. So 1 minus 1 over 1/4, which is 0.75. So it's a nice formula. So suppose a probability distribution has a mean 5 and standard deviation 1. What is the probability that an outcome is between 3 and 7? Then you can use this Chebyshev inequality, and you'll find that it's 0.75. All right, so we'll finish the video here and we'll pick up on the next one.